All right, we can get started. So I didn't really get a chance yesterday to uh, introduce myself. I'm Clark. I'm your Python instructor for prep. My wheelhouse here at Galvanize is directly concerned with technical teaching, um, some curriculum involvement, but mostly my involvement is directly with students, interacting with people, doing one-on-one mentoring, um, and lectures and study hall. So you can find me doing, and I know Tovio mentioned this as well the other day. You can find me doing study halls every Monday, Tuesday, and Friday. Most Mondays, Tuesdays, and Fridays. Sometimes things get backed up, and study halls are kind of a low priority. So just be forewarned that I reserve the right to cancel study halls on kind of short notice if I need to focus on other things. Um, so do feel free to reach out. I'm available for one-on-one mentoring if need be. We're all mostly available for that. I can take a little bit to get back to folks on Slack, so sorry if I've kept anybody hanging, but you're always welcome to reach out, and I will get back to you eventually. Usually, sometimes it can be a day or two, but I will get back to you as soon as I can. Yeah, so my background, just really quickly, I'm dyslexic. I've struggled in academia as a student, not for lack of interest, but an often lack of useful accommodations and just kind of, I think, just stigma around teaching staff with giving those accommodations. So you will see me misspell things, mistype things, get syntax errors. I'm going to make a ton of mistakes, and want you to notice that I want to cultivate a skill with y'all where you're thinking about not avoiding making mistakes because you're never going to write any code that way, but getting good at when you see an error, catching it and knowing what it means, reading the error, figuring it out. I would literally not be able to do anything without that skill. And turns out that amongst my peers, most of whom are also not dyslexic, or just not dyslexic, um, this holds true as well. So you'll see me do this. You'll see Tovio do this as we code. So just be forewarned. If I'm reading something and I get something wrong, now you know why. I am a Galvanize grad. I went through actually the web development immersive, which was somewhat of a precursor to the software engineering immersive. Right before we acquired Hack Reactor, we had the web development immersive, and there was enough overlap between those two programs. We decided to kind of synthesize the two and kind of do best of both worlds with those two programs. So that basically, sort of turned into what's now the SEI. I did that I graduated in 2018, and my goal in going in was to like come out as a competent programmer where I could go and kind of find my niche in technology. I didn't have a specific idea. I just knew I wanted to be in tech and I wanted to write code. And specifically, I was interested in language theory, like programming language theory and programming theory, paradigm theory, that kind of stuff. And ultimately, given my struggles as a student, I, by necessity, became very interested in programming pedagogy. So I didn't actually plan to get a job at Galvanize. It's just they happened to be hiring. And after I graduated the web development immersive, I went out and just started trying to pick up other languages just for the challenge. And one of the first ones I picked up was Python. And it just happened that they needed somebody who knew Python to give the Python interviews in the DSI, and I was around the building a lot. And they're like, "Oh, didn't you pick up Python after the WDI?" And I was like, "Yeah." So I started part time and kind of worked my way into a teaching role, which is great because, like I said, I've really picked up an interest over the years, given my struggles as a student in academia. I picked up an interest with pedagogy. So yeah, so that's what brings me to data science. I am very much a programmer first and a mathematician second. So my statistics is completely through the lens of programming. So you'll see me if we when I cover statistical and mathematical concepts, it'll be in the context of programming. But we'll get to that stuff sort of later on in the class. So yeah, that's me in a nutshell. That's a quick history, what brings me here, and I'm excited to be starting this class with y'all. I'm looking forward to interacting. I want to clear up a couple things, just make sure folks are comfortable with the Slack channel. I know it can seem like, I hope it doesn't seem like we're like cracking down on the way people are using the Slack channel. It's really kind of not a big deal, but if for people who might see us like deleting comments that aren't in the class thread, it's not like us going like, these kids, they just won't listen. You know, it can, I know it could seem like that, but we want you to use the Slack channel. It just, we notice that it helps if we just like kind of nudge you in that direction of like how we want you to use it kind of early on, and say like outside of lecture, definitely feel free to use the premium prep Slack channel. Feel free to use the basic prep Slack channel, and commenting in threads under each post is a good way to keep things on topic and keep things clean. And then it works smoother for everybody. So don't take it personally if I deleted one of your comments from the main channel that was meant to go into the Slack channel, or if I DM'd you, or if anything like that. It's just to help us get on track so we can use the Slack channel as best we can. But do feel free to make maximum utilization of it. Okay, let's start getting into the material. Let me get my screen share up and running. It'll be this one. All right, can folks just give me a quick thumbs up on screen if you can see my screen all right? You see my text editor? Okay, I'm seeing thumbs up. Good. Let me get everything situated here. All right, so also one other quick note, do feel free in the thread, if you post a question in the thread, I'll get to it as soon as I can. Just do @Clark, and then it'll try to auto-complete the @ symbol, you know, @around symbol, and then no space, and then my name, and it should say like Clark, Associate Technical Instructor. I forget exactly what my handle is, but it'll auto-complete, and then ask your question, and I'll see it. I'm more likely to see it that way. If you post it outside of the thread, I probably just won't see it until after class. I have Slack up on my phone, and all I can see is the thread. Okay, cool. So let's get into things. So last time we ended on the, oops, I am scrolled down. We were talking about comments. We made it to the section on comments. So hopefully we'll get through all of the rest of day one and day two as well. So quick note on what you're looking at here. This is my text editor. There were a number of really good questions. I really like these questions about like what environment to choose. And I kind of weighed in on this, but you know, I'll just give a quick note on environments again. You're going to hear a lot about IDEs. IDE stands for Integrated Development Environment. VS Code calls itself an IDE. It kind of is. I really don't consider it an IDE personally. It's kind of a very, very, very feature, I'm going to say feature rich text editor environment. So you'll hear the term IDE and you'll hear the term text editor. Certainly an IDE allows you the ability to edit text. And a text editor has integrated features that allow you to code in a nice way and can automate some things. So there can be some overlap, but we generally use those terms kind of loosely to just describe sort of the role that tool plays, or sort of the niche that it fills. So this is the Atom text editor. This is what VS Code, this is the open source editor that VS Code is based off of. I learned on it, and like I said, I just love it. So this is my preference, but VS Code is really similar, and most of what you'll see me do, everything you'll see me do is basically pretty directly translatable to VS Code. If you're looking for an environment to start off with, we recommend VS Code. In general, if you're looking for other environments or play around in other environments, we tend, and I said this before, I would tend to push you towards a simpler tool like a text editor rather than a more complicated tool like an IDE, even though VS Code calls itself an IDE, which is just what it calls itself. Okay, so that's what you're looking at here. There's several panels. Obviously, I have tabs. I can switch between different files. I have the rendered version of the Markdown class slide file. So this is on the right-hand side. This is rendering kind of like you'll see it render in GitHub. So if you go to the class files, every time we post the link to the class and the class documents, if you click on those class documents, you're going to be seeing what I have here displayed in my editor, rendered in my editor on the right-hand side. So the theming is different, the colors are different, but it's still the same stuff you'll be seeing. It's the class materials that you'll see on GitHub. So the expectation is that you will click on those and either follow along, like either on GitHub, or you can pull the repository and follow along locally as well. But that's sort of a different thing. All right, so for the third time of me saying this, let's actually get into the materials now. All right, so we left off yesterday on comments. So this is the first thing we're going to talk about, where in addition to writing whatever code that is going to be executed on the computer, it's useful to be able to write comments in plain language that is meant for you and I to read as developers, so that we can comment on the code as we write it. You may be familiar with conventions of other languages. I know some people might have done some C or C++, or even Java, other sort of languages like that have a convention around, that you should comment a lot or most of your code. Convention is in Python is to leave small amounts of documentation where necessary, and then in general, Python is such a readable, friendly language. I mean, at least compared to like C and C++, it's so readable that it's meant to be, or it's thought of as what's called a self-documenting language. So in general, the code is meant to speak for itself. The code is meant to be kind of easy to read and self-document. So you don't need to document every line or comment every line, like is convention in some other languages. So if you're used to that, I won't be doing that in Python, and I would discourage you from leaving a ton of comments. However, sometimes it's necessary and useful to leave just quick notes here and there, just a little something here and there so that you can see what's going on. Sometimes it can help annotate things really quick. And also, if you look up here, this is a line of Python code. Excuse me. This is a line of Python code that's going to display the word hello to my terminal here. So if I actually run this, and I just run it, and it's kind of waiting here, but it's going to run. Oops. Don't mind this line at all. You see nothing, you see nothing. Okay, this is just gonna give me some space, so it'll clear the output a little bit. Okay, so this is just going to print the word hello. I can print hello world just like this, right? So this is a valid line of code. By valid, I mean it's a bit of code that is legitimate Python. It is valid Python. So Python will run this. Notice how this other stuff here, and I can put in whatever I want in these comments here. All this is just going to be ignored by the interpreter, by the Python interpreter. It's just going to look through this and be like, oh, these are comments. Well, I'm just not going to do anything with these. So one really common use for comments is you're working on something and you need to to nullify some specific line of code. Maybe there's a line or a few lines of your code that it's throwing an error, or just doing something that you don't want to do, and while you're debugging, and you just want to isolate things down. So you want to just turn off some of your code. You can comment it out, and that's what we say. We'll say commenting out. So I can comment out this line so I don't get that string printed. And if I run my code, we'll see it run here in a second. It's kind of slow. Apologies for that. You can see nothing prints now because I have this commented out. So I turned this valid code into a valid comment, and now the interpreter is just going to ignore it. So this is a really common thing to do, especially with print lines. As you're debugging code and solving problems, you might want to put in several print statements in various places. But if the output starts to get kind of messy and hard to read, you might want to comment a few of those out before you delete them. And then once you get everything working, you go through and delete out all your commented print lines and things like that, just so your code is like clean and nice to read. So cool. All right, so we have two types of comments. We have a single line comment. So a single line, well, it exists on a single line. I can put valid code in front of it. So if I print hello, right, I can put the single line comment on the end of the line. And this is something that I'll really commonly do. If there's some line of code that I want to just give an explanation for, I'll just leave that explanation on that line, on the same line just after it, right? So there's no way to like leave a comment in the middle of the line comment. There's no way to do that. You can comment out the whole line or everything right of this hash mark, right? So in order to do that, you can literally put in the hash mark. For me, it's shift 3, just a regular hash mark, and then everything to the right of that hash is going to be commented out, right? You can also, if you're on a Mac, it's Command / or the question mark key. And then anywhere my cursor is, notice how my cursor is in this hello here. So I'm going to hit Command / and that's just going to comment out whatever line my cursor is on. So I don't have to like navigate to the beginning of the line and hit shift 3. I can just get a nice regular comment, turn it on and off with Command / I believe on Linux and Windows, it'll be Control / in most environments. That should be the case. So this is a single line comment. If I come down to the next line and try to continue the comment, right, then you can see it's highlighting differently. Notice how my syntax highlighting changes, and it's no longer highlighted like the highlighted like the comment above. So that tells me it's not a comment, so I have to comment it out on the next line. Sometimes if you want to leave like a short paragraph or multiple lines of comments, it can be a lot to like have a bunch of lines that start with a hash like this. So there are multi-line comments as well. And I think I hear somebody's mic on. If everybody doesn't mind, if you don't mind just checking your mic really quick and making sure you're muted, that would be good. Thank you. Cool. So for multi-line comments, we can use, so this is, you might know this as a single tick quote or an apostrophe key. In Python, we think of this as a single quote. I'll usually call it a single tick quote. You have single tick quotes and double tick quotes. You can surround the thing that you want to comment in 2 groups of 3 single tick or double tick quotes. So this is exactly the same as this. I always get people asking me like, okay, well, if you have the single tick multi-line comment, what's the difference between the triple tick multi-line comment? There's no difference. These are exactly the same. So yeah, no difference there. They work exactly the same. What I can't do though is if I start with single ticks, I can't like end it with triple or with double ticks like that. I have to end it with single ticks. So notice there's no spaces here or anything, just right in a row. If I put spaces in it, you can see, well, I don't know if you can see it, it's kind of a light color change. It goes from a light green to white, or sort of a gray white. But that does change the syntax highlighting. And that's one thing, this is one thing to pay attention to, like develop a little bit of an eye for how your syntax highlighting is changing. And you know, like learn the colors of your syntax highlighting. And you know, if I see something that I expect to be a string or a multi-line comment and I see it and it's white, I know, oh, well, that should be green. So, you know, somewhere maybe, you know, maybe I left off one of the quote marks, or I have a space, or I have an extra quote mark or something. Well, that's actually working, but yeah. So there's a number of things that can help you discern a potential error in your code. Cool. So that's single line and multi-line comments in a nutshell. And the takeaways for this is if you just want to leave a quick annotation above, below, or on at the end of a line, you can use a single line comment. If you have multiple lines, short paragraph, problem statement, doc strings, which are a form of internal documentation, you can use a multi-line comment. To do a multi-line comment, you use a group of 3 matching single tick or double tick comments. Cool. All right. Oh, this is another good one as well, another use case, right? So another use case is for leaving to-do statements in your code. And there are formal workflows that are sort of built around this. You know, you've got a big project to do, and you have a lot of functions to write for it, and you might think, oh, well, you know, I can already tell I'm going to need, you know, 10 functions that, you know, each need to do whatever job, and they'll say to do write factorial is prime next prime function, whatever, you know. So you can leave in to do items so that you can remind yourself what you need to do when you come back tomorrow, or there's sort of a difference between like inventing what you need for the solution. Sometimes that's obvious kind of up front, and then you get into the weeds of working on a specific problem, and then you can forget like kind of where you're headed. So to do statements can be or leaving yourself to dos can be good for keeping you on track. Cool. All right, so some basic Python constructs. Everybody here already? Well, okay. Common data types, simple operations, and assignments. Actually, I'm gonna just do this. I always like to do this. You'll see me use comments a lot just for kind of formatting things. This is a comment switch. And this is something that I do that I'm not sure really anybody else does, but it allows me to turn on and off very easily by commenting out this top line some section of code. So multiple lines of code. So I'm going to use these to kind of format different sections so it's clear, you know, as we move on to different topics, everything is kind of bite size. Okay, cool. All right, so common data types. So what's a data type? There are various types of information. There are various schemas or ways of dealing with information differently, right? Like take this. Is this the number 6? Should it be treated as a mathematical value, or should it be treated as the ASCII character or Unicode character that represents the 6th character, right? So there are different ways of representing data that may make it make the way you deal with it change based on its type, right? So you want to have different data types for representing different kinds of information. So there's a variety of types. We're just going to look at a few simple ones today. One quick note here. I should talk about this. Python has a variety of built-in tools called functions. There are other kinds of tools that are not functions, but one of the kinds of tools is a function. And a function just is essentially it's a container that you define somewhere and then invoke somewhere else. It's you can think about it like a container of like reusable logic, right? So you can write an algorithm once and then employ that algorithm by invoking that function, or quote unquote calling that function, invoking that function definition elsewhere in your code. So one of the most useful functions built into Python is print, the humble print statement. So what print does is the way we use it, I'll type the word print, and then after print, I'll put parentheses. The parentheses come after a function, tell the function that it needs to be invoked, that it does actually need to run the code in the function. And then inside the parentheses, you can pass what we call arguments. So print takes any number of arguments, and what it does is it displays those arguments onto the console, onto the terminal. So right now I'm running my code in this terminal, and it's going to execute the code. So if I say hello, I mean, I just gave this example above, but so I'm just describing this because we're going to be making a lot of use of print. We're going to be using print a lot, and I don't want that just to come out of nowhere. All right, so there's another really useful function, and we actually have to, in order to see what this function does, we have to pass it to print. There are other uses of the type function that don't involve passing it as an argument to print, but type does something a little different. Remember I said print takes in whatever you pass to it, and it makes that visible on the console. It just displays it on the console. Type has a little bit of a different thing. So it takes in an argument and it returns Python's, well, it returns the type of that argument. It returns whatever Python calls that type, right? So let's look at the number 63. So what is the type of 63? If I do this, and I know some of y'all are going to do this and wonder why it's not working. You'll say, what's the type of this thing? And you'll run your code and it'll run, and we didn't get any output. Why don't we get any output? Because if we want to see what type gives us, we have to print out type, right? So type gives something back. It might seem like print gives something back, right? Like print you might look at print and say, oh, well, it gives it back by making it visible in the console. So what I mean by gives something back or gives an output, print doesn't really have an output, which might sound weird because, I mean, it sure looks like you can see the output of print, right? Because you're literally seeing it. We don't think of print having an output. We don't think of it having a value in the same way as other functions because it doesn't give back a data type, right? So type does give back a data type, and the information that it gives back is, wait for it, the type of the thing passed to type, right? So if I pass this number 63 to type and I want to know what type 63 is, and then I pass that type to print, you can see Python says that this is class int, right? So it calls its types often, we'll use the word type or class or object sort of synonymously. So it calls this type class int. So yeah, that's what that does. So the reason I'm talking about these is like, you know, these are the first two functions I'm teaching you, and I got to tell you, they're probably the best two tools in your tool belt for figuring out what's wrong with your code, which is something that you'll need to do. You'll need to develop that skill. I know a lot of you, and it's okay. This is fine. You know, it's a safe place for this to happen, but I know it's going to happen either way, even if I say it, but I want you to be on the lookout for it. Like, some of you are going to want to tend towards writing code that avoids errors. You know, if you're a more advanced programmer, you know, okay, fine, you know, challenge yourself to write it right the first time, whatever. But I don't know, even still, like, an error is not a bad thing. I know Tovio mentioned this, you're gonna hear me mention this over and over, because it's something that I needed to hear, that I think most of us need to hear over and over. Errors are not bad things. They're there to make your life and your job easier. Errors don't exist for no reason. You know, they don't just exist because your code is broken. There's not just magically an error there because you didn't do it right. They exist because some developer, so the people who are developing the Python programming language, took time out of their day and often a lot of time to craft errors that are consistent and well written and readable to make your life as a developer, as a programmer, easier for catching errors as they come up. You will produce errors. Like I said, I will produce errors. You're going to see me produce errors. You're going to see Tovio produce errors. It's just part of coding. So don't try to develop the skill of never getting an error. Try to develop the skill of being good at fixing them, right? So your two tools that are going to save you time and time and time again are print and type. So it should tell you something about the importance of these, that these are the first things that I teach. They're great. Okay. Okay. So integers, floating point numbers, and Booleans. So these are just the short names: int, float, and bool. The full names for these are integer, floating point numbers, and Booleans. So these are the three numeric types, and we'll kind of see here. Integers and floating point numbers are what we are familiar with as numbers. Booleans are technically, in Python, they are considered a numeric type, although they only have two possible values, right? Like, if you think about what are all the possible values of an integer, well, there are infinity integers, you know, and there's two infinity integers if you go negative, if you include negative and positive integers, right? Obviously, there's just infinity integers, right? An integer is any positive or negative whole number. So it does not have a fractional or quote unquote decimal value. Floating point numbers are a fancy computer sciencey term for decimal numbers. There isn't any other nuance to it than that. It's what you're used to calling a decimal number. The reason we don't use the term decimal is because you may know decimal refers to the base 10 counting system. And as computer scientists, we have to think in multiple bases. We have to leave the possibility of thinking in multiple bases open, right? So there's a number of other bases that you'll develop some familiarity with over time. We're not going to dive super deep into like thinking in binary and hexadecimal and things like that. It's just a skill that you'll kind of pick up by osmosis over time, and if you want to like develop that on your own time, then that's fine too. But obviously I think probably everybody knows at this point, computers operate on a binary system. You have high and low voltage states in transistors in your silicon crystal components on your motherboard, right? And those components measure high and low voltage states that are analogized as zero, quote unquote, 0 and 1. There really aren't zeros and ones. Those are what euphemisms, or what do you call it? Like abstractions that are useful for us, right? So the zeros and ones on the computer level are high and low voltage states of your CPU and your RAM, etc. There's various ways of storing and utilizing that binary information. So we do think of computers as being binary, and as such, you encounter numbers like powers of 2, which are significant in binary, easy to represent in binary, but strange and hard to represent in decimal. There is virtually no useful parity and sort of synchronous overlap between decimal and binary. I know of no mildly complex number that is easy to represent in both. So as such, when we talk about numbers, often we sort of talk about them in a base neutral way, and floating point is a way of describing a number that has a quote unquote point value, or a decimal value, or a fractional value that isn't associated with strictly a base 10 number. So that being said, numbers in Python are expressed in base 10. Lucky for us, right? Unless you could import maybe some special library that handles numbers in hexadecimal or in binary, or there are ways of converting those that are built into Python as well. But just generally, a regular number is expressed in base 10. So 63 is what you think it is. Fortunately, there's no trickery there. So let's look at, we know what that integer is. Let's look at a floating point number. So 5.0 is a floating point number. If I print this out, well, surprise, surprise, we're gonna get 5.0. I don't even wait for that. 5.3, 0.9, I don't know. 0.0 is a float, right? So if I called type on these, it'll say that these are all floating point numbers, and the term that it uses is float. Cool, and like I said, so there are infinitely many potential integers and floating point numbers. You could say that there's even, infinitely, the space between two whole numbers is infinite when you factor in the ability to have fractional values, right? So floating point numbers and integers, we don't think of having as a set limited amount of numbers that they can represent. In practice, there is a limit, right? Like your computers are what's called a finite precision system, or finite precision machine, which means that there is a number that's too large to represent. Let's say it's like 2 to the 256th or something. It's some power of 2. I forget exactly what it is, but it's a huge, huge, huge number. And there is a level at which a floating point number becomes so precise. The more decimals that I add to this, we talk about this becoming more and more quote unquote precise, right? And this, I mean, just by looking at this is way too many floating point number, or way too much precision for Python to be able to represent accurately. So if I try to print that off, well, actually, let's do this here. I'm printing the type. If I try to print that off, you'll see it'll get shortened. Right, so it can only represent up to this point, right? It's just physically incapable of doing more than that. There are ways around that. There's kind of ways of chaining operations that people use to represent extremely precise numbers, although that is a whole different can of mustard or something. So yeah, we won't be getting into that. We'll just be using regular floating point numbers. Okay, so that's ints and floats. Let's talk about Booleans. Booleans have two values, true and, can you guess? False. True and false. These are the only two valid Boolean values, true and false. That's it. These don't look like numbers, do they? But they are. They're considered a numeric type, for whatever that's worth to you. These ints and floats are numbers as you're used to dealing with them. Booleans just happen to be a numeric type. We happen to consider them a numeric type. And we'll sort of get into, there will be things that come up later where that will make more sense why that is. But for now, just know that we call it a numeric type and they don't look like numbers at all. Cool. So let's look at, I mean, if I can print out, I can display values that I don't need to display, right? It's not that useful for me to just say print true, right? Because I mean, if I'm just going to type the thing in and just have it displayed, I'm like, okay, but it's not that useful yet. Or print false, right? So let's look at some other ways of abstracting information that kind of make these tools make more sense. Well, let's look at some type operations first, actually. Let me do this. So I'll comment out this whole thing. Get another one of these blocks. There we go. And let's look at another, let's look at some type operations. So when you're understanding, there are various types in Python. There are several built-in data types that are worth learning. When you're learning a new type, and there are other types that are not built into Python, other data types that you can potentially create yourself, or that you'll import from other third-party libraries or other first-party libraries, whatever, that just are not in the default prelude in Python, so they're not imported or included by default. But we'll be talking about the default ones, the built-ins. And whenever you're learning a new data type or a new class or object or whatever, whenever you're learning a new type, you can, I guess I could break this into two categories, right? Or two channels. One way of understanding a type is when and where and why would I want to use it, right? So when and where why would I want to use numbers? Well, to do math, to count things, to do math and count things, I guess, the various things that we use numbers for. It should probably be pretty obvious why numbers are useful. So, so that's an easy one, but there, you might also ask, like, when and where might I want to use a Boolean, right? That's a little less obvious. We'll be using Boolean values a lot, and that'll become obvious why those are useful as we go. But so think about that. That's one avenue. Why is this useful? When would I want to use it? Where would I use it? And another question is, how do I use it? How do I apply it? What's the valid ways of utilizing this? And that gets into type operations. So the way of understanding how to use a type can be understood through what are the various operations that apply to that type, right? So what are some operations that we can do with numbers? Well, we can add 5 plus 3. Anybody know what's going to print to my console here? Go ahead and put it in Slack. We have a question here. Sorry, I didn't see this till just now. Does Python have a double precision type? Yes. We're not going to talk about it though. So for anybody wondering what a double precision is, it's a floating point number that is capable of being twice as precise as a single precision number. Okay, so what do we got? What's the consensus here? It won't print anything. Oh, y'all are sharp. I can't sneak anything by you. Okay, all right. I thought I was being clever. I'm like, haha, they're gonna say 7. I mean 8. Jesus, 8. They're gonna say 8. But y'all know nothing's gonna print because I didn't print it. So that's great. Already, I can't get anything over on you. All right. So that's going to print 8, right? So I can say 5 plus 3. So fortunately, and this is going to work. I'm not going to show this with ints and floats, various, because it's going to work the same with ints and floats. So I can have a various types of operations. So I can add 5 and 3, 5 minus 3, 5 times 3. So notice the multiplication sign is the star for me. That's shift 8, shift and the number 8 on my keyboard, and that gives me a star key. Single slash will do division. Now here's where things start to get a little funky. So notice that the single slash division, these are both integers, but I get a float out, right? And it's important to note this. You can think about any type operation, and we'll develop this more, but type operations can fall into, I'm going to say 3 categories. You might dice this, somebody else might dice this up into, 1 category or more categories or 2 categories or whatever, but I'm going to say 3 broad categories. Either you have an operator like you do here, right? This is a built-in operator. These symbols are built-in operators into Python that perform an action, right? So each operator takes inputs. You have a left and a right-hand operand in this case. So that's one type of type operation. Another type is a function, right? So print is a function, type is a function. So these are operations that apply to actually any type, right? And then another type is a method, and we'll get into what methods are later. So yeah, so these are just your standard mathematical operators. So notice it's important when you're understanding whatever kind of type operation it is, whether it's a function or a method or an operator, think about understanding that particular operation in terms of its input, its process, and its output. And most of the time, you can ignore the process. Most of the time, you don't really care how it works. I don't care what happens under the hood when I say 5 plus 3. I just know that it better give me 8, right? So I know that its inputs, the inputs 5 on the left and 3 on the right, should give me the output of 8. This expression, this bit of code should express the value 8. And we'll use that word express to mean to give back a value. So this should give me back the value 8, which it does. And it gives it back as an integer because it can. If this were a float, if one of these were a float and the other one was an int, I said I wouldn't do this, but look at me go. Then we're going to get a float in return, right? So we can combine integers and floats across operations. If there's a mixture of the two, you're going to get a float. If you have two floats or one float, you're going to get a float. If you have two ints, you're probably going to get an int. But notice we have two integers here, and we still get a float out. And that's good behavior because we want this kind of precise style of division. But there are other styles of division. If you remember doing like long division, if you were taught long division like I was in grade school, you'll remember that the kind of answer, the kind of quotient you get tells you how many times something goes into something else, and then it also gives you a remainder of how much is left over that you're not able to completely put in, right? So if I want that kind of quotient, there's an actual name for this, but I can use the floor division operator, which is a double slash division. Sometimes I might call this double slash division. The formal name for this is floor division because it rounds down to what they call the floor. So if I do 5 over 3 here, this will tell me that 3 goes into 5 once, right? It's also, it turns out, extremely useful to be able to get the remainder of something. So to get the remainder, and this is considered a type of division, this is saying 5, give me the remainder of 5 over 3. So if I divide 3 into 5, 3 goes into 5 once with a remainder of 2. So I can use the percent sign to ask for the remainder of a floor division operation, okay? So if you want to know the remainder, you'll use the percent sign. Now, unfortunately, this is not called the remainder operator. It'd be nice if it was, because that's how most of us would think about it. This gives us the remainder of 5 over 3. And you can think about it that way in your head. When you see the percent sign, think, what's the remainder of, A over B? The word that I'm going to use to describe this is the modulo operator. And for short, I'll call it mod. I won't go into why this is. There's a whole thing about modulus arithmetic, and you'll hear like clock arithmetic, and there's sort of a big long story behind it that we're not going to get into, but you can go research that if you're curious. For now, know that it's called, and I will henceforth call it, modulo or mod. That is its formal name. And when you hear me say that, you can think remainder. If you want to describe it to yourself as a remainder, or to me, I'll know what you mean if you say remainder operator. But if, outside of this class, if you call it the remainder operator, people will be like, you mean modulo? So yeah. So it turns out it might seem kind of like oh, well, that's neat. There's an operator just for that task. It is wildly useful to be able to get the remainder of something, because it tells you it can tell you if something is a factor of something else, right? So let's say, well, let's come back to that in a second. But we can use this to determine if, say I have, some number A, and I want to see if some other number B is a factor of A. I can say if A mod B equals 0, then I know B divides evenly into A because it has a remainder of 0, right? Or maybe I want to know if it's, maybe I'm interested if it's not a factor. So if A mod B is not equal to 0, then I know B is not a factor of A, and then maybe I can, I can use that to determine what other code I should write, or what my program should do. Okay. So that's modulo. Let's talk about variables. Let's change gears a little bit. So variables. So not a whole lot. This is not a complicated concept by any means. Just a little thing, but an important one. To this point, I've just shown, using numbers and printing them out. We looked at some basic type or some basic type operations. You now know enough to use Python as a calculator, right? You can, well, you will once we cover variables, excuse me, but you can do basic calculations sort of with Python now. And let's look at variables, and that'll really kind of round things out. So let's say I want to capture the product of two numbers. So I'm just going to call this prod for short, and I'll say prod equals, now this is a single equals sign. This is not, I want to make this clear right out of the gate. This is not a check for equality. This is an assignment of a value to a name, right? The name part of the variable we call the identifier. This we call the assignment operator. So the way we would say this formally is prod gets, let's say 7 times 3, right? So prod gets 7 times 3. And if I print prod, then prod will have captured whatever the result of 7 times 3 is. So 7 times 3 is a mathematical expression that expresses a value. It gives us 21 back. So this evaluates to 21, expresses, meaning gives back the value 21, and then is set equal to this identifier. Remember, the name part of a variable, prod here is the name of it. That's the identifier. That's what identifies this. If I print prod, I should see 21. There we go. Cool. So I can do this. I can say A equals 10, B equals 37, and I can print A plus B, and I'll get 47. So I can treat the identifier, I can treat this variable as whatever its value is, right? So I don't have to do 10 plus 37 here, which is useful when maybe I don't know, maybe I want to write an algorithm. What if I wanted to write an algorithm that gives me the sum of two numbers over 2, right? Which is the average of those two numbers in this case. So the sum of two numbers over 2 is the average. So let's call this AB average. AB average. AB average equals A plus B over 2. Notice how I'm using parentheses to control my order of operations because I want A plus B to happen first, and then I want to put that over 2. And then I can print out AB average. So when I'm naming variables, these are not special names that are built into Python, right? This does not need to be called prod. It could be called puppy feet or something adorable. You can give it as adorable of a name as you want to give it. You can call it gibberish or whatever. Well, you can't have a semicolon in there, but these are names that I get to decide on. So when you're naming variables, it's useful to you'll see this when you get over the hump of understanding the syntax of a given language. When you become an accomplished programmer, the hardest part of programming left is naming variables. So it's something that you want to do with a little bit of grace and a little bit of caution. Like I see, I'm doing this, I'm breaking my own rule here, calling these A and B. In general, I'll see people do this thing where they'll say like X and Y, and they'll call everything X and Y. Or they'll use single letter variables because that's what they're used to in algebra or something. The nice thing about uh, Python or a programming language, you get to name this whatever you want. So take the time to give it a useful name that helps you understand what it is and helps you remember what it is. And you might think, oh, well, okay, whatever. I know what it is. I just put it there. I know what that is. But you would be surprised. And uh, me telling you this is probably not going to prevent you from having to learn it the hard way. But it's something worth mentioning anyways. Um, Take the time to give things good descriptive names that are going to help you think about what they are, because it'll save you a lot of work. And there will be someday there'll be a problem that you're solving, and you went through and you named everything really quickly, and you've got X's and Y's and G's and uh, Q1s and Q2s and PFs floating all around, and you're like, I have no idea what's going on. And then you'll go, well, since I don't know what else to do, I guess I'll just maybe I'll do what Clark was saying. Maybe I'm stuck, so I don't know. Maybe I'll just rename some of my variables, and you'll be in the middle of renaming something, and it'll just click, and you'll understand exactly what you need to do. But before you do it, go change the rest of the names so you don't have things that are renamed one place and not renamed somewhere else. So when you change the name of something, it becomes, the longer you take to change the name, right? Like if I call this Y here, and then I use like Y all over my code, I have to go change this everywhere, right? So something better, whatever. So that's the thing. That's the longer you wait to give it a good name, the more work you have to do to like uproot the old bad name and carefully put in the new better name. So it's worth taking some time to give some things a good name. So the naming, there's a formal naming convention or casing convention, we call it in Python, which is that when we have words that we want to separate, you may be familiar with there's camel. There's camel case. I think this is camel and this is Pascal. Gosh, I used to know. There's camel casing, there's Pascal casing, there's kebab casing. So Python kind of sillily uses what's called snake casing, which is underscore separation of words. So when you want to delimit words in a variable name, I can't just say AB average with a space here. This is going to be an error. If I try to run this, Python's going to be like, I don't know what you mean. We'll wait for that error to show up here. So it says syntax error, invalid syntax. So it's just saying like, this is not valid code. I don't know what to make of this. So in order to tell it that I want these names connected, I'll put an underscore to separate the words, right? So AB and average are going to be separated with an underscore there. So that's the convention, and it's helpful to follow that. Tovo made a mention of this, that there are things. If you want to learn more about Python coding convention, there's the PEP8 style guide. There are other good resources. Python is the Python community tends to be pretty oriented, especially around PEP8. So people generally stick to that convention. There are times to break convention, and there are times not to. Either way, it's good to know it, and you'll just learn. I still learn about PEP8 and programming convention here and there as well. So there's always more to learn. But there are certain things that I do are, I do them my way because it's my preference and it's against convention. But and that's okay. It's okay to break with convention on certain things. Certain other things, like, I really would stick with underscore separation because it really standardizes code in in a nice way. That being said, it is your code. You can do what you want. If you have another convention that you like better, whatever you do, just be consistent. So if there's some other way of doing things that you prefer, the most important thing is to just do it that way every time. So in general, like we'll talk about strings later, when I make a string, I will use double tick quotes. Convention is to use single tick quotes. I just like the way double tick quotes look better, and I can use single tick quotes as apostrophes inside of them, which I find myself needing to do fairly often. So it's my preference to do that. But rather than sort of mixing and matching, I'm committed to always using double tick quotes unless there's some other sort of exceptional reason to not do that somewhere. So, which generally there's just not. Okay. So that's notes on convention and naming convention. Cool. I've got a lot of lag here. Use the type function to discover the type of the number 74. Well, I gave this example. We're going to skip this breakout. This will give us an integer. I do suggest that you write this in. We've got a lot of material to get through, so I just want to keep us going. Go ahead and write this in, even though you see this. Go in your Replit or whatever coding environment you have open. Write that in and print it out and run it, and you should see the output. Or maybe you'll get an error, in which case you can practice the most valuable skill of debugging. Okay, simple operations. Well, we talked about this: plus, minus, multiply, divide. Order of operations follows PEMDAS, right? And it really follows this. I'm sorry, I didn't talk about exponentiation. I left out one of the operators. Oopsie. So if I want to raise 5 to the power of 3, I can do star star is the exponentiation operator. Some people will ask, well, you have plus and minus, you have times and divide and modulo. So where's the square root operator? If you raise a number to a fractional exponent, 0.5, this is the square root. Another way of doing this is 1 over your, the nth root is the index, right? So 1 over the index, where the index is 2. So this is also a square root operation. This will give you the square root of 5. Anybody wants to see the square root of 2? If you find that to be an interesting number, there it is. Okay, so that's exponentiation as well. No, name A is not defined. Whatever. There we go. Cool. So PEMDAS. So PEMDAS, if you recall, is parentheses. Come on, we got a lot of lag right now. I don't know why. Parentheses, exponent, multiplication, division, 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 addition, and subtraction. Okay. So this is your order of operations. I get a lot of people that look at this and they're like, okay, I'm gonna have to really commit this to memory so that I know how to write things with as few characters as possible. And I suggest just thinking about which things you want to combine and just surrounding them with parentheses. So if I want to do, a, where was that? This num average thing. Let's do this. So A equals 10, B equals 37, A plus B. So this is going to be different, right? Because DA, right? So division comes before addition. So it's going to put B over 2 plus A. So this is going to be A plus half of B, which is not what we want. So don't worry about thinking about like whether or not you should use parentheses. Just assume that you should use parentheses. So if I assumed that like that I should use parentheses for this, I'm just going to say, okay, well, I know I want to do the sum of A over B, or of A plus B, and then divide that by 2. If let's say I wanted to do A plus half of B, which is not the average, I would do this even though the order of operations would do that also. I'm just going to do this anyways. Just why not? Why not just put parentheses in there? So when in doubt, just use extra parentheses. It'll save you down the line. I see a lot of people kind of make this mistake in like the spirit of like using a minimum of parentheses, and I'm like, but why? They're useful, and there's no, it's free and it's going to save you a headache at some point, right? So when in doubt, too many parentheses is better than too few. If you want to be an ultra math whiz and brain it out every time, I guess I can't stop you. But if you want to just produce working code, more parentheses is going to get you there. Erring on the side, at least for now, of more parentheses can be a useful thing. Okay. All right, so shifting gears again, duck typing. So some of you may be familiar with other languages. You may have background in C or C++ or Java or another language that has a different typing system. If you're familiar with JavaScript or Ruby, I believe those are both duck typed as well. I know JavaScript is. There are other common duck typed languages. So what duck typing means is literally, if it walks like a duck and it quacks like a duck, you can treat it like a duck. So if it's reasonable, if it seems reasonable to add a type integer to a type float, then it should be possible to do. And as we've established earlier, I can combine these, even though these are different types, I can combine them in an operation. And that might not seem revolutionary, but that takes engineering to do that. So if it can work, it should work. So Python's typing system uses type inference to infer the type of this. So I don't need to say int 3 plus float 4.5, right? If you're coming from a different language, well, this is not really, doesn't really reflect how Java works or anything. But if you're coming from a different language, for example, where you have to annotate the type of your variables, you might be used to saying like int num equals 3 or something. If you're coming from like C, something like that. In Python, we don't have to supply any type information. It's just inferred for us by the context. Okay. I'm going to pop this in Slack. I know it says 5 minutes. I do want to keep us moving, but I want to give this as a little challenge. I'm going to keep lecture going for anybody who wants to do the breakout. Feel free to just put your answer in Slack. Oh, and I'm sorry, we have a few questions here. Somebody's asking, why do I have spaces in the functions? I tend to just put spaces in where I can, just to give things kind of room. It helps I think it helps my particular like reading challenges to just have more space, have things spread out a little bit. And I think it makes for prettier code. It's strictly an aesthetic thing. So when I put extra spaces in the functions, it doesn't change how the function works. It's not required. It just kind of gives things some visual relief and breathing room, so it's easier to see kind of what's going where, rather than just kind of everything being crammed together, right? You know, for example, I could do this. Well, here, let's copy this first, right? Ask yourself which one's easier to read. You know, imagine this going on, you know, twice or 3 times as long, and this is a simple algorithm. But yeah, by convention, this is all convention, standard Python convention. But often I will put additional spaces. This is not convention. Often I'll put those additional spaces in there just to kind of give some things some breathing room. Let me know if that helps answer your question, to the person who asked that question. Okay, cool. Seems like we're doing good. We got some answers coming in, and I see lots of parentheses. Very nice. Okay. Cool. So that's the end of the first slides. Whew, we still have more to go. This is a dense day. I'm apologize. I'm gonna skip the break today. Oh God, Zoom, please. I want to get right into the actual material here. Oh gosh, this is, yes, there it is. All right, so day 2. Let me just do this real quick. Okay, cool. On to day 2. So this is what we were meant to do today, but we didn't get through the slides yesterday. So this has sort of a review of common data types, int, float, bool. We just talked about those. Simple operations, assignment operator, and some more scalar types. So this is a lot of kind of review of what we just did before. So this will get into some more operations concerned with Booleans. So we looked at mathematical operations that we're used to, adding, subtracting, multiplying, dividing, etc. So those are, I think, probably familiar to us. Let's look at some comparison operators. So comparison operators compare something, they compare their left-hand operand to their right-hand operand. So if I say one way of comparing things is to see if they're equal, right? So think about this. So this is going to take in, on our left we have a number, and on the right we have a number, and this is going to check if they're equal. So notice this is 2 equals signs. And this is why I made a sort of a minor stink about this. A gets 10, right? With this example, this is not an equality operation. This is an assignment. We're assigning the value 10 to the identifier A. We're assigning this value to this variable. We're making a variable here. This is checking equality. That's what that's doing. It's checking if two things are equal. And it evaluates to a Boolean value. So this, it's either true or it's false that 4 is equal to 8. It happens to be false because 4 is not equal to 8. This expression is false. One thing I want to take a second here to keep this in the back of your mind. This is not invalid code. It's just the value false. I've encountered this with a number of people, and I remember going through it myself when I would look at a problem and think, well, I don't want to do that because it would be, I don't want to make that comparison because it would be false, and then my code would be broken. The value false just means not the value true. It doesn't mean your code's broken, right? So this is valid Python. It's just not all that useful because we already know that 4 is not equal to 8. But what if I wanted to see if a was equal to 8? Well, in this case, I know what the state of a is. It's an integer. It has a value of 10. It's easy. But what if this is coming from somewhere else? It's a variable that's been determined by various other parts of my code, et cetera, and I want to know if I can't know what this value is ahead of time, right? So we have some value a, and we just want to see if that value a is equal to some other value 8, right? Again, this is also going to be false, but maybe we have some other value, other value b equals 10 as well, and we'll say if a equals b, and this is going to be true. If we change the value of b to 11, this is going to be false. There you go. So this is a comparison operator, and it compares, specifically it compares for equality, right? So I can also see if b is not equal. So there's a not equal operator, and this is really useful. It's really useful to have a not equal operator. So is it true that a is not equal to b? It's false because a and b are both 10, so a and b are both equal, right? What if I change it to b is 10.0, so b is a float? So notice that this is still the same, right? It's still true that a and b are equal even though they're different types. So this is checking the value, not the type. So these will be equal across the types, even though they'll be equal if they have the same value, even if they're different types. I can also see if, let's make this something else. We'll make b 11. I can see if a is greater than b, if a is less than b, and if a is, greater than or equal to b, or less than or equal to b. So these are all my comparison operators. Equal, not equal, and notice that this operator is exclamation point and equal sign, not equal. So is equal, is not equal, a is greater, a is less than, a is greater than or equal, a is less than or equal to b. So these are very useful operators, and I think of these as Booleans, and I think of them as Booleans because they give me a Boolean back, right? If I notice we're getting true and false here, it says true, false, or false, true, false, true, false, true. That's kind of neat. Notice I'm getting Booleans back, and that's because, or I think about these as Booleans because they give me a Boolean back. So, and I want to plant this seed now. When you see an operation, whether it's a function or any kind of operation occurring in Python, try to see it as the value that it returns or the value that it evaluates to, right? Apologies if some of those terms are if you don't know them yet, you will soon. But try to see this as a Boolean because it evaluates to true or false, right? That's what I'm trying to get at here, right? So we can do, I'll say false. Oops. And I'll just say oops. True. There we go. So numeric type encoding, this is a bit of a side note. This information is not immediately relevant, but it's worth mentioning now because it'll be relevant on down the road when you learn about type encoding. If you ever take a computer science class on like how something that covers how a float and an integer are stored and dealt with on your CPU and on your hard drive or in your RAM, they don't appear to have anything to do with each other. They're very different set of moving parts. Floating points are, I think it's safe to say, more complicated because you have we think about it, we call it a floating point because we think about that decimal point as floating to some position in that number. So we just define the string of numbers and then we decide where that decimal place goes, where that floating point goes. So it has to have ways of storing that. Like I said, this won't be as immediately relevant now, but it's a tidbit that might come in handy, might be useful to know that later. Duck typed, we just talked about duck typing. Walks like a duck, quacks like a duck, must be a duck. The data type is automatically inferred. Given ability to share operations between data types through, quote, type inference. Operations, casting. Let's get into casting. So let's say A equals 12, and I want to say B equals float A. So I can convert one type into another type. There are a number of functions built in that bear the name of the types that will convert one type to another type. So here we have an integer 12 and we want to convert it to a float. So what's that going to be? If I print B, what's that going to give me? $12.0. Yeah, somebody, yeah, there you go. God, I don't know, there's something kind of funky because I don't know why my interpreter runs so slow. Y'all got it in there before my interpreter got it. Cool. So yeah, so this is going to give me 12.0. So imagine, let's try something else. Let's say I have 12.347 and I want to cast it to an int. What's that going to give me? That's just going to give me 12. So when you cast a float as an int, it's just going to truncate or just chop off this last bit, right? So if we do this, right? So notice, even though this is close to 13, 12.99, right? It's just, all it's going to do, the behavior is that it just cuts that tail. So it just cuts off all the stuff after the decimal point and throws it away. It doesn't do anything fancy with rounding. So it's a nice, simple, predictable behavior from casting a float to an int and an int to a float, right? An int to a float is just going to put a 0.0 after it, and it's going to be technically a float rather than an int. So it's useful. There are times when there are particular instances where you'll need a whole number value, like an integer. You'll need an integer and not a float. Even if your float happens to be a whole number, you'll need an integer. So it's useful to know this behavior. And now we're getting into, this is what I'm talking about type operations, right? We looked at some operators. These are functions, and I would still consider these part of learning about ints and floats. These are operations, and we want to know their behavior, right? We want to know what their inputs are. Float, the input to float or int is anything that it can convert into an int or a float, and then its output is int or float, respectively. Oh, I haven't done enough with bools yet. What's this going to give me? And I'll leave it to you. Go ahead and put it in Slack. A equals 12.3. B equals bool of A. Bool is short for Boolean. It's the type specifier in the built-in function to cast things to a Boolean value. Yeah, so this is going to give me true, right? So it's important to note that if you cast, and I'm just going to do it like this, if you cast a number as a Boolean, and there's times where this information will genuinely become useful. If that number does not have a value of 0, then it will be true, right? So even if it's a very small float, right? So notice integer 8, integer 0 are true and false respectively. Float 0.0 and float 0.1 are false and true respectively. And the same thing, even if you have a negative number, so negative 837 is still true, right? You might think, well, a negative number, well, that would be, it's like negative, so maybe that would be false, but a negative is still true. A negative number is still true when cast to a Boolean. Same goes for floats. Negative floats, negative 0.0003 is true when cast as a Boolean. Cool. Okay. Arithmetic operators. We went through this. So just talking about the basic arithmetic operators. Addition, subtraction, division, multiplication, exponentiation, and we got some parentheses in here, right? So this last one, it's worth mentioning, is going to be, so remember, parentheses first, then exponentiation, right? So we want to do 2 plus 2 first, so we put that in parentheses, raised to the power of 3 minus 2. So whatever the difference of 3 minus 2 is, which was just 1. So 2 plus 2 is 4. 3 minus 2 is 1. So 4 to the first is just 4. All right, this is a quick one. I'm going to put 2 minutes on the clock. We'll actually do this one. Excuse me, let me just get this formatted here. So I'm going to pop this in Slack, and you can reference that in there. Okay, cool. You didn't see the solution. Pretend like you didn't see the solution. You totally didn't see it. It was an illusion. It's a good time to open up for questions too, a little bit. Have a little question intermission if you want. Like I said, let me get a couple minutes on the clock here. So if you do have a question, go ahead and just put it in Slack. Please don't unmute your mic, by the way. Not yet. We can do that after I end the recording and when class is over. Okay, I'm gonna post in just a screenshot of the solution right there. Feel free to wrap up if you want. I'm gonna post in another breakout as well. Also, I know this is going fast. If you're new and this is a new thing, we don't expect you to necessarily be able to do this. The idea, we don't expect you to be able to you know, get in the answer. And some of these are short. It can be a bit of a challenge. So don't worry. The utility, as far as we see it, is to get you thinking about it, right? To get your fingers over your keys and get you doing something, thinking about it. At least for the breakouts, that's a legitimate success. So here's another breakout. And I'll paste in the solution after 3 minutes. Oh, we have a question here. How do we print the box around around our code in Slack? It's the backtick key. It's kind of a intend to use it. I've never seen a use for it outside of programming languages, honestly. They can't show Slack while we're recording here, so this might be. I'll try to demonstrate this as best as I can in my editor, if I can just remember how to use Zoom. Okay, there we go. So to do that formatting thing where it kind of looks like a coding, like a formatted code cell in Slack, if you type 3 backticks, it will automatically give you sort of a monospaced formatted window that you can type in, and it'll sort of look like code. It's easier to format that way. So your backtick key, just to be clear, is not your single tick quote key, double tick quote key. These are the same. These are on the same key. This is not the key that I'm talking about. It's a different character. It's called a backtick. I'm on a Mac right now, and on my keyboard, it's below the escape key, to the left of the 1 key, and above the tab key. And that's generally where it is on most keyboards. So it's kind of a weird one. If folks still want help with that, I can screen share Slack after the recording's over. After class is what I mean. There you go. You got it. Nice. And we got another question here. Sorry. Where are we doing this at? VS Code or Replit or what? If you need an easy place to start, Replit is fine. VS Code, if you have VS Code installed and set up and you know how to use it, then you can do that. But yeah, whatever coding environment of your choice, and then you can just copy paste in your answer into Slack when you're ready. Oh yeah, somebody answered that. Yep. Okay, go ahead and get your answers in. I'm gonna paste a solution here. Now, why are these done? This is like done in, okay. Feel like this solution could have been made a little tighter, but whatever. Okay, there's a little screenshot of the solution. You can take a look at that when you're ready. Oh, I was totally just presenting my screen. You could have seen it. Okay, whatever. That's fine. This is a review of day one, which we literally just went over, so we don't really need to review that. Casting, assignment, incrementation. Okay, here we go. So let's talk about this. So it's common to want to, well, let's talk about this first. So let's say I have a variable x, and I know I just said don't use single letter variable names, but whatever. We're, for demonstration purposes, rationalize, whatever. So I can set some variable equal to something, and then let's print out x. Oops. Let's print x, and then I can set it equal to something else. Cool. So this is fine. You can set a variable and then set it to something else later. This kind of behavior can cause some confusion, you know, if you're using a variable name over and over and you change it at one point and think it's the thing from before, but you change it and you forgot you changed it, right? So it's just something to be aware of, but it's a mechanic that we take frequent advantage of to assign a value and then reassign it to something else. Quite often, very often, you will want to assign a value, a new value to a variable that is related to its current value, right? So you might say x equals x plus 3, and this is totally possible. X equals x plus 3. So currently x is 3. So what this is saying is the new value of x is equal to whatever this is. So the thing on the right, the part on the right of the parentheses, that evaluates first. So x plus 3 evaluates first. So just ignore that left hand part of the parentheses. X plus 3, this should make sense, right? X plus 3 is x plus 3 is 6. I'm sorry. 3 plus 3 is 6. So x plus 3 is 6. So I'm just saying x equals 6. This evaluates first. X, which is 3, plus 3 is 6. We get 6 out of this, and then that goes into the new value of x. This is such a common, this is called an incrementation or accumulation. Really, it's an incrementation operation. It's such a common thing to do, to say, you know, a equals a plus something or a equals a minus something, that there's a shorthand way of doing it. And it's called, this is called, this kind of shorthand of something is called syntactic sugar, which just means it's like throwing sugar on it just makes it a little sweeter. So this just makes this kind of thing a little bit nicer to do, since it's something that you have to do all the time. But to be clear, even though these two lines look pretty different, line 42 is exactly equal to line 43. These two expressions or these two assignments are exactly the same so far as Python is concerned. When Python sees the plus equals, it literally turns it into x equals x plus 3, right? This doesn't just work with plus, it works with any of the operators that we saw before. So it's really common to just add one to something. Let's just do this. Let's say, okay, I'll start over. So let's say a equals 0, a plus equals 1. This is a really common thing to want to do, to start something at 0 and then use it as a counter, right? So, you know, you're gonna have dynamic code that will kind of deal with things in different ways, and you might want to count something. So you can use this kind of thing as a counter to count various events, right? So we can say 1, 2, 3. So I run this 3 times and print a. We'll see a equals 3. And like I said, we can do this with any other operator. So we can do minus equals. This turns into a equals a minus 1. Times equals, division equals, or slash equals, floor division equals, mod equals. I can't say use that a whole lot, but I have seen it used. Typically, you'll use plus equals or minus equals. These are very common, sometimes the other ones as well. But any of them are possible, so it's just good to know that. Okay, so did we really quick? Oh, okay, yeah, that's fine. That's incrementation. When we want to increment, or you could think about minus equals as a decrement, but I don't know, increment, decrement, it's the same kind of thing. It's just whether it's going up or down. So I'll probably just call it incrementation either way. But yeah, I know it's technically a little bit wrong to call it that, but so be it. Scalar types. What is a scalar type? A scalar type holds a single value, so not a group of values. It holds a single values. It is immutable, meaning that the type itself can't change. All the types that we've looked at are scalar types, simple types. Some other types, scalar types in Python are string, none, complex, and byte, and tuples not in here, although it should be. Complex and byte, we're not going to cover in this class. These are sort of more obscure. You can learn about them later. You won't need these for the TI, but they are technically scalar types in Python. Integers are positive or negative whole number values. You can cast other scalar types to integers using the int function. Using the int function on a float will always round it down to the nearest whole value. Floats can be thought of as continuous while ints are discrete. Sometimes we consider two float values to be essentially equal if the difference is below some threshold. Underflow, we kind of looked at an example about this. Remember earlier when I said print out this really high precision floating point number, and it only printed out the first 15 characters of it, and then it'll round whichever that last character it prints out to whatever it thinks it can. So this is this is a calculation error, really. It's a lack of precision on the computer's behalf, and it's called underflow. So if I print out 0.99999999999, yeah, this should give me 1.0. Nope. Do I need to do another one? Okay. There we go. Okay. So there's a few off. What is this? 1, 2, 3, 4, 5, 6, 7. 17. That's weird. Okay. Whatever. So 17 17 decimal places of precision, right? This is giving me 17 decimal places of precision. I thought it was 15, so I don't know. Yeah, I'm not sure why that is. So this is called underflow, where you have a number that's too precise for Python to really be able to handle. I mean, I can write it in my text editor. It's just characters in my editor, but as far as Python is concerned, it can't compute this as that precise. So it's just going to call it 1. The reason I mention this is that, I mean, honestly, probably this is not going to be a problem. Probably not going to have to worry about that. There may come a day, though, when you're working on a problem where you need to deal with extremely precise numbers, and it's not going to work for whatever reason. It's not having it, and it's useful to know that this phenomenon can occur, so that you can work around it. And there are ways to work around it, although that's neither here nor there for our purposes. Booleans, either true or false, can be 1 or 0 when cast to a numeric type. Non-zero and non-empty values return true. Result of comparison operations, which we looked at, is a Boolean. Let me look through here really quick. Strings, none, breakout. Oh yeah, okay, we're almost through. Good. So strings. Okay, so there's a bit of another shift of gears here. Strings are a data type. They are Python's way of representing textual information. So in order to declare a string, we use quote characters. Now, like I said before, convention is to use the single tick quotes, a pair of single tick quotes, excuse me. I've got the hiccups. To use a pair of single tick quotes, and this delimits, meaning shows the limit, the beginning and the end of the string. And I'm just going to call this my string equals this. So now I can just put whatever I want. I can say hello world and print my string, and I'll see hello world printed, right? So what if I want to, here's why I don't like to use single tick quotes. What if I want to say hello worlds? I want to use an apostrophe at some point. Well, the apostrophe character is a single tick quote. It's the same character. Python just sees that character as a string delimiter. So even though single tick quotes, I don't know, they look a little cleaner, they interfere with apostrophes. So what Python sees is that I'm ending the string here after world, and then I have an S and then a single quote that doesn't end, so an incomplete string. So this is going to give me a syntax error. It's either a syntax error or a this isn't defined. Yeah, invalid syntax. So I like to use double tick quotes because I find myself in strings using using apostrophes more often than using quotes in the string. Now convention around this is to use what's called the escape character, which is your backslash character. So if I put a backslash in front of this single tick quote here, it's going to say, hey, don't worry, that's not the end of the string. I just want you to ignore it and just treat it like a different character. Treat it like its own character, right? So that's called the backslash is called the escape character, and this will print hello worlds. So this will make this into a valid string. I personally think this is a little ugly. You can disagree. Evidently, the people who develop Python disagree, but I don't know. I just use single tick quotes consistently, or double tick quotes, and I do this consistently. I've thought about this, and I do it every single time, unless there's some, the way I'm combining things requires that I change it to a single tick quote. So the rule for my code is that I like to use double tick quotes because I just find this a little prettier. So you can do what you like. You can follow convention and use single tick quotes. You can do what I do and use double tick quotes. Like I said, whatever you do, and when you're learning, you can kind of play around and mix and match and figure out what you like, which I suggest doing. But you want to be thoughtful and aim for something consistent. Wherever you end up, it should be, okay, I always use single tick quotes, and if I need an apostrophe, I use an escape character. Or I always use double tick quotes, and if I need quotes, I use escape characters for those. So just whatever you end up doing, whichever convention you end up adopting, just make it consistent and your code will be beautiful. Okay. None is another, let's see, let me make sure I covered strings here. Yeah. Okay. Let's cover strings a little more, sorry. So concatenation, if I have the string hello space and I add it to the string world, this is kind of intuitive. Hello plus world should equal hello world, right? So this is valid. It might look a little funny or not, but you can add strings. When we add strings, we don't call it adding. We don't say we're adding. Well, honestly, sometimes I will call it adding. The formal language around this is concatenation. We concatenate two strings together, meaning we add them together like this. So you might think, oh, well, I guess I can use subtraction. You can't use subtraction. I don't know what it means to subtract world from hello, and neither does Python. Interestingly, you can multiply a string by an integer. So let's multiply hello times 4, and we're going to get hello, 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 hello. Or we could say hello, hello. Hello times 2. Cool. And a quick note on none. None is its own type. It is a unary type. For contrast, Boolean is a binary type, meaning it has two possible values. None has only one value, and it's its own type, right? So if I print the type of the value none, its value is type none. So it is a valid type. It's its own type. Print, weirdly, actually returns none. So if I print, I get none. That will become obvious why that is later. And I want to be really clear about this. It says it right here. None is not the same as the numeric value 0. The reason none exists is there are times when you want something to exist that requires a value, but you don't want to give it an explicit value. Maybe you want to set a variable, my variable, equal to none, because later on it might need to be, you might say my var equals a string, and then later on you might say my var equals an int. So you might initialize it as none. There are various things that none is used for. What's important to know is that it will show up. Functions without explicit outputs will return none, such as print. And it is not, absolutely not, to be confused or conflated in any way with the numeric value 0. 0 is a numeric value. It is not the absence of a value. None is the absence of a value. It is not the numeric value 0. If you make that mistake, I'm going to care a lot less than it sounds like. I feel like I'm like really harping on this, like, don't make this mistake, but I don't really care. It's not a big deal if you make the mistake. But it's just, I wish somebody had told me that. Once upon a time, there was a day when I had that realization, and it was like a grand epiphany. So there you have it. So here we have one last breakout. We're a couple minutes over time. Sorry about that. I'll wrap up here. Y'all are free to go. Wrap up your night. Have a good rest of your night. Or if you want to stay on for questions, feel free to do that as well. Let me stop the recording here. Again, here we go. All right.